So if I move this now, I can point to things. I wasn't able to point when I had it as full screen. So we're going to talk today about inverses. Now, in order to do an inverse, we have to do something called a determinant. Okay. Determinant. Okay, and this is going to tell us whether or not we can find an inverse. So to find an inverse for any matrix, we'll call A. All right, that looks like this: A, B, C, D. Okay, A, we're pointing A, B, C, D. I still can't point on it. Okay. So my mouse. Anyway, I'll have to figure this out later. But anyhow, so there's your determinant. There's your matrix. Now to find the determinant, you are going to do A, D minus B, C. And it's that easy. You do have to know the formula though. I'll probably give it to you on quizzes and tests and things like that, but make sure you have it written down. So let's just do an example. Say I have A equals 3, 6, 5, 9. Okay. And so we're going to go A times D, okay, 3 times 9, minus B times C, 5 times 6, 27, minus 30 is a negative 3. Now, to find an inverse, this number must not be 0. So since it's negative 3, yes, we can find the inverse. If it were 0, we could not. All right, and that's just a rule. So I would always search for a determinant first. If your determinant is 0, you cannot find the inverse. So let's do another example really quick. Oh dear. That's for tomorrow. So let's find the determinant for matrix B. And we will look at it like this. We're going to go 3, 2, 7, 4. And so we're going to go AD, 3 times 4 minus 2 times 7, which is negative 2. So yes, I can find the inverse. Now how do we find an inverse? So we need another formula. Okay. The formula for an inverse. Now, inverse looks something like this. We're going to call it A to the negative 1. That means the inverse of matrix A, or B or C or whatever, looks something like this. 1 over the determinant of A. Okay, so that's why you need that number. So when we actually find the inverse for this matrix B, we're going to use this negative 2. Okay, and then you're going to have another matrix that's going to look like this. We're going to reverse some numbers and some negatives. D is going to come up here. So remember, D was originally in this spot right here. D was originally in this spot right here. Okay, we've moved it to the A spot. Okay, B stays in the same place, but we're going to make it negative. Okay. C stays in the same place, but also we're going to make it negative. And A is going to be where D is. All right. So again, formula that I don't expect you to memorize. Okay, but you do have to be able to use it. So I have 1 over the determinant of A. D moved, A moved, and B and C became negative. So let's go ahead and find the inverse of this matrix. Since I can't point, I'm going to go ahead and make it full screen anyway. Okay, so save space. We need to see both of them. All right, I'm going to write over to the side here. So if we want the inverse of matrix B, we want B negative 1, we're going to go 1 over negative 2 times. Now remember, we're going to put D in the A spot. Okay. B is going to stay the same, but it's going to go negative. And C is going to stay the same, but we're going to change the sign. Remember, if it's negative, it becomes positive. And A is going to go in the D spot. So now we're going to simplify. So B negative 1 equals negative 2. And I did this by multiplying this number by everything, this 1/2, this negative 1/2, by everything on the inside. And then I have a positive 7 over 2, and then a positive 1, and a negative 3 over 2. That's my inverse. Now, the question might be, first, why do we need an inverse? Okay, well, remember we talked about coding. We're going to use inverses for coding. But inverses also come very handy when we learn how to solve systems of equations. So this is something we're not just going to stop using after we're done with this lesson, okay? Inverses are going to come up again. So, but I want to show you what inverses do. If we were to multiply both of these, I'm going to erase so that I don't have to change screens. We're going to multiply b times its inverse. You get a very interesting matrix. So if I were to take, oh, I lost b. Yeah. Okay, so if I were to take this matrix 3, 2, 7, 4, and multiply it by my inverse here, -2, 1, 7 over 2, -3 over 2. I want you to see what happens. And this part right here is not something you're going to have to do. This is if you have the so what factor, you want to understand why this works. Okay, so this is a why this works. All right, so we're going to go ahead and multiply these two matrices together. All right, so I have 3 times -2 plus 7 times 1. And I have 2 times -2 plus 4 times 1. And I have 3 times 7 over 2 plus -3 over 2 times 7. And I have 2 times 7 over 2 plus 4 times -3 over 2. So if I were to add these all together, we actually end up with something very interesting. This is a 1, this is a 0, this becomes a 0, and this becomes a 1. So when you multiply a matrix and an inverse, what you get is what's called the identity matrix. Okay, again, that's going to be really important when we start doing systems of equations. We're not going to get to it totally in depth in this class. It's more important when you get into some of the higher level maths, linear algebra and whatnot, but we will use this just a little bit. Let's go ahead and do one more example just to make sure we've got this. So let's find the inverse of, we'll call it matrix C. 2, 3, 1, 4. Okay, so the very first thing I have to do is to find the determinant. Okay. So I have 2 times 4 minus 3 times 1. That gives me 5. So I can find the inverse. So then the formula for the inverse is I'm going to put my 1 over my determinant. Okay. And I'm going to multiply it. I'm going to reverse A and D again. So 4 and 2. B and C become negative. And I multiply out. So I end up with 4/5, -3/5, -1/5, and 2/5. You will find quite a bit that inverses often have quite a few fractions in them. So homeworks on Khan, you have 2 assignments. One, you are finding the determinants, and the second one, you're finding the inverses.